In this video, we will introduce proton NMR spectroscopy and understand how chemists use it to determine the structure of molecules. Molecules are extremely small to see. Even powerful microscopes cannot directly show us the exact arrangement of atoms in most molecules. So chemists rely on indirect methods to determine the structure. The solution? Spectroscopy. Spectroscopy provides structural clues. One important technique used by chemists is spectroscopy. Spectroscopy studies how molecules interact with energy. One of the most useful types of spectroscopy in organic chemistry is proton NMR. The name NMR stands for nuclear magnetic resonance. Nuclear refers to atomic nuclei, meaning nuclei involved. Magnetic refers to the strong magnetic field used in the instrument. Magnetic field used. And resonance refers to the absorption of energy. Energy absorption. Here are the three basic ideas of NMR. In an NMR experiment, the sample is placed in a strong magnetic field. Sample placed in magnetic field. Next, radio waves are then directed at the sample. Radio waves applied. Lastly, when the conditions are right, hydrogen nuclei absorb this energy. Nuclei absorb energy. However, not all hydrogens in a molecule are identical. Hydrogens in different chemical environments respond differently in an NMR experiment. As a result, they absorb energy at different positions. So hydrogens in different environments behave differently. Different environment means different absorption. Let's take the example of ethanol. We have CH3 hydrogens, CH2 hydrogens, and OH hydrogens. The NMR instrument provides a spectrum with peaks. Each peak corresponds to hydrogen nuclei absorbing energy in a specific environment. Each peak equals energy absorption. Considering the example of ethanol, we will expect 3 peaks. The horizontal axis of the spectrum is called the chemical shift. It is represented by the symbol delta and measured in parts per million or ppm. Typical proton NMR scale begins from 0 to 12. A signal further to the left has a larger chemical shift and is described as downfield. Higher chemical shift equals downfield. A signal further to the right has a smaller chemical shift and is described as upfield. Lower chemical shift equals upfield. Chemical shift increases from right to left, starting from 0 ppm to 12 ppm. The first clue in proton NMR is the number of peaks. In general, the number of peaks tells us how many different proton environments exist in the molecule. Consider ethanol again. So the number of peaks equals to number of proton environments. Consider ethanol again. 3 environments equals to 3 peaks. So in summary, MMR helps determine molecular structure. Hydrogens in different environments give different signals. Chemical shift delta is measured in ppm, parts per million, and the number of peaks show the proton environments. So in this introduction video, we have learned why chemists use proton NMR, what the spectrum represents, what chemical shift means, and why the number of peaks gives us an important clue about molecular structure.